solution of exam 3, the Python part. Let's see, I start from scratch, so the people who want to do really the exam, so the exam fully, know how to reach the network directory and things like that. Okay, so first of all, you receive the paper, and you have to reach the network directory, ubz01fst. Okay, I take for granted that you have watched the pre-course either for Windows or for Mac. I'm on a Mac because it's a computer on which, honestly, it's more difficult to reach it. Okay, so, Finder, this is not needed, go, connect to server, okay, here you digit this thing here, only up to here, cursor is not really necessary, but if you want to digit it anyway, SMB, okay, Samba, it means colon, // it's exactly the opposite slashes that you use in Windows. Windows users digit only this part, but with the slashes in the other direction. Okay. Okay, I have already digited, so I click here. Connect. Okay. The password for the server. Wait, because name is unibz.it and the slash. This one. Let me see. This slash here. If you have a German keyboard, good luck. To produce this slash, Alt Shift 7. Then your login name, your university password. Let me see. And the flag, remember this password on my keychain. Connect. Cross the fingers. Okay, I'm connected. I'm inside courses. Okay. Now, exam colletti. Don't ask me why exam is not inside exams, but it's inside courses. Exam colletti. Here you will find a directory with your name. Okay, I find it. Okay. Usually the best, you can work online, or the best strategy is to copy everything on your desktop. Okay. Or you can work online if you're able to. Now, I don't close it, I iconize it because I will have to put things back here. Okay, I'm working on Python, so I have to start Anaconda, which, if you are at exam, I take for granted you have installed it and know it very well, better than me, how to install it. Come on. And check it before the exam, because you never know that the day before they change something. I launch Jupyter Notebook. 3 hours. Come on. Okay. Desktop. Exam. Okay. Okay, you find what you have to do already written here. Let's see, may I increase the... Yeah, so use it better. Build the function convert grade, which takes as parameter a number and returns a string. So def. When you read what the function, this thing here, you immediately should start with the beginning of the function, convert grade. Okay. And colon. So, return the string A, B, C, D, E, F. It's basically a conversion from Italian degrees to American degrees. Okay. So, if the grade is above or equal 100, it returns A. So, N above or equal 100, return A. Easy peasy. Elif, no, else if, n. From 90 to 99. Well, you can write it in this way. Okay. But you can write it also in this way, which is also correct, because you have already checked that it is larger or equal to 100. Okay, it could theoretically be 99.5. Okay. But I assume that n it's an integer. Let's write an integer number here, for the few. Okay, so now you are sure that it's never 99. Okay, so in this case you can write it like this, or you can write it even in this way. Okay, so yeah, yes, both work. So all three work. This one is fine because you're sure that it's integer. Okay, return B, semicolon, elif, same thing here, 80, 89, so 89 larger equal and larger equal 80, colon, return C, semicolon, elif, 66, no, 680. Now pay attention because here 1999, 80, 89. So here there is a mistake. 79. I will have to correct it when I will give it. Luckily, I produced the video before I give the exam. So here it's 80 and here it's 79. 79 equal n larger equal 66. Return D. F. If you commit, oh sorry, the semicolon are not needed in Python. I always forget because I'm used to other programming languages. Okay. If you commit the destruction mistake, for example, here you write for mistake 69 instead of 79, I would obviously not consider it. If you instead commit a mistake in all the inequalities, I would consider it. Okay, so that's it. Let's see the example. Convert grade. It's not mandatory to check it, but okay, first, okay, now convert grade 78 D. Fine. Okay. I save. Remember to save. Don't complain with me if everything crashes. Okay. Build function sum with previous, which takes as input a list L of numbers and returns a list of numbers containing the sum of each number with the previous one, starting from the second one. Pretty strange. So, def sum with previous. Okay, it gets a list of number L. Okay, now what must it do? Well, it must return a list, so you have to prepare a list return. Okay, and we will append the elements one after the other to this list. So it must go through this list. So for x in L. Okay, what do we have to do? Let me see. Let me think. No, we cannot start from the first one because the first one deserves a special treatment. The first element doesn't do anything. So, let me see. Temporary sum equal. Let's set the temporary sum equal to the first element. This requires a little bit of thinking. Temporary sum set to the first element. Then for each element in the list, starting from the second, how can I start with the second? Well, you have the first alternative is to use the indexes. So you start from index 1. Okay, the second alternative is this one. I have seen it. 1 colon. This one will create a list starting from the second. So you either use the indexes or you start from the second using this trick here. Now for each element starting from the second, what will I do? Well, first I will temporary sum equal plus equal, I will add it to the temporary sum, then I will r.append temporary sum, and then I will set the temporary sum equal to x. Okay, I think we have done it. Let's see whether it works. First of all, I execute it. Okay. Sum with previews. Let's see. I put this example so you can test it also easily. Nothing. Ah, yeah, if I don't return anything, return R. Yes. Okay. Can it be improved? Can we do it in another way? Yes, we can improve it and do it in a lot of different ways. For example, here do you see we store a temporary sum, which is basically only one element, then we add the next one, and then so we could do something like this instead. And at this point, I don't call it temporary sum anymore, I call it previous, mean the previous element. Okay, so I remember the previous element. This is just an improvement. Another thing you can do, it is an alternative, not an improvement. Let's do it here, sum with previous 2. It's using the indexes. So you use the index I, for example, in a range 1 colon len of L. Okay, and then append previous plus L of I, and here L of I. So you can do it also like this. Let me see. Well, if you do it like this, you don't even need the previous. Yeah, if you do it like this, you can look L of I minus 1. Yeah, it works like this. This works also fine. This is a perfect alternative. Okay. The important thing is that if you do like and you don't need to remember the previous. Wow. If you do like this, take care that you really start from 1, otherwise I minus 1 will be broken. Okay, let's see whether it works. Yeah, it works. Okay. Let's comment here alternative solution. Okay. Save. Build a function rammed-up strings, which takes as input a string containing a sequence of words separated by spaces and returns a string with the words, sorted them alphabetically and removing all duplicates. Okay. Def ramdup strings. It wants a string, so S colon. Okay, what does it do? So this string contains a sequence of words, like this one, for example. So, let me see. Okay, we have a way to split a string. Okay, it's a function. He used the split method, yes, in fact. Okay, so we put a string in a list, we call the list L equal s dot split. Okay, we have seen this method during the course. Now in L is a list of all the words. Okay, we have also a method to check whether a word already appears in the list. So we can go through this list, put the elements into, for example, a string. So we can go through this list for x in L. Let's write capital L, because otherwise I confuse it with number 1. I go to the list, okay, and now I check whether the element how can I check whether an element exists? I have first to sort them alphabetically. So this is easy. L.sort. Okay. Now that it's sorted alphabetically, it's easy to check whether an element already exists, because it's maybe just to help you. List sorted. Just to help you doing the homework, doing the alphabetically. I write here how is the list and how is the list sorted alphabetically. So the list will be something like this. Okay, with obviously the quotation. I won't put all of them, don't worry. Okay, now the list sorted alphabetically will be the same, but sorted alphabetically, so we start with and then and again and then what do we have? And it's already gone, and it's already gone. Hello, yeah, hello, then hello again, hello, then makes, again, I forgot again it's here, again and hello makes, perfect, then practice, and then world. Okay, okay, just to help the people. Oops, line, okay, so now we have sorted it, so we have it like this. Okay, now it's easy, can you see it's easy to spot whether a word has already appeared, because it means that the previous word was the same. So if how can I remember the previous word? No, the only way to remember the previous word is using this thing here, range. If L of I it's equal to L of I minus 1, in this case we don't do anything. So I don't put it. Only in the case it's different, in this case I put it in the new list, so let's call it L2 dot append L of I. Okay, we have to create here L2 as an empty list. Okay, this thing here has a little problem, that L of I minus 1 doesn't exist at the beginning, so as before I start from 1, and L2 for the moment it's L of 0, 0. It's a list with the first element. Okay, now that we have the list, no, I don't need to append it actually to the list. I can create the string directly. The string is the first element of the list, L0. Now I attach it to the string, so s2 equal s2 plus the space plus L of I. Okay, let's see whether it works. I have to test it because this is pretty complex. If I don't return anything, I have to return it here. Return s2. Again and hello. Okay, let's put here the fact that it's a string, so quotation and quotation here. this to help you. Okay, again, and hello makes perfect practice. Yes, perfect. Okay, there are other alternatives. If you, for example, don't want to sort it before, well, it will be much more difficult to spot whether an element is duplicated. Okay, in this case, you will have to go through all the list. It's really a mess if you don't spot it before. Okay, if you don't sort it before. You could do it with a dictionary. In these two cases, if you're able to do it, you have my congratulations. I was able to do it even without sorting it before, so sorting it after, but it was really a nightmare. The code becomes much longer. So let's put here space return. Which synchronous of rows separated by spaces. Let's write here some suggestion. Converts them into a list using function, using method. I write some suggestions, so and comma and puts the words into a string separated by spaces, skipping those words which are duplicated. Sorts them alphabetically. Okay, now with this suggestion it should be much more straightforward what you should do. Okay, save. Find the average annual simple return and the average annual logarithmic return for forward f in the period 2006-2008, printing it with an appropriate sentence in percentage form with 2 decimal digits. Something we did 200 times during the course. So import pandas, import numpy. It's logarithmic. Yes, so we need numpy. From pandas data. I remember it's open book, so this you can copy and paste from another code. Okay, so now prices equal wb.dataReader. It's Ford data source equal Yahoo, for example. If you want to get it from another provider, fine. Start equal 2016-0101 and equal 2018-1231 or something else. No, I think that's fine. Let's check. Come on. Okay. Yes. I need only the adjusted closing price. Yes, so I don't need anything else. So I forgot to specify ADJ close. Okay, fine. Now what do we do? Threat, because this is a simple return. I use the vectorization, so I do it once. Prices divided by prices dot shift 1 minus 1. Don't forget the minus 1. Or better, if you forget it, at least check what the values of sret are, and you will see clearly that they are completely out. lret equal numpy.log prices divided by prices dot shift 1. Here don't add the plus 1. Okay, let's just check. I will see the average, so the average of sret equal the annual, so the average is the mean, so is sret.mean. Okay, it's annual, so I have to convert it to annual. Do you remember that it must sum 1 raise to the power of 250 the number of and subtract 1. LRET, it's much easier to convert it to annual. So annual LRET equal LRET.mean. This is the annual average SRET. This is the annual average LRET. LRET.mean, and then by 250. It is the reason why people often use logarithmic return, because it's easier to convert them to annual. Okay. Now, a print the average annual return simple. For Ford is, and I have to add how many? 2 decimal digits, so round SRET, comma 2, and with the percentage symbol, no, wait, by 100, let's see. Error. It complains that you have to convert it to string. -11, very nice. Okay, and now I copy and paste for the second one to see. Ctrl V. The average annual log return for this. Okay, fine. Save. Using Monte Carlo technique with a drift equal to average log return minus 1/3 of the variance calculated from 2016 up to now, make 15 graphical prediction of the price of Ford starting from tomorrow and going on for 200 trading days. This requirement is completely incomprehensible if you have not obviously studied. So if you are watching the exam before having studied, well, don't expect it to understand. If you have studied, you will see that there is a lesson dedicated on exactly this thing. You just need to copy the things one after the other and adapt them to what we need. I think we have everything except matplotlib. Matplotlib.pyplot as plt, and scipy maybe. Import scipy.stats, no, from import, because we need the normal distribution probably. Okay, now let's get the prices. To see, I copy here brutally. Okay, well, until now, so I remove the end. Okay, now we need the logarithmic return, numpy.log prices divided by prices.shift 1. Okay, let's calculate the drift. Drift equal, the drift is the average log return, so LRET.mean, okay, minus LRET.var, 1/3 of the variance, so divided by 3. Okay, calculated from 2016 up to now. It's 1/3. Don't copy simply the exercise we did in class, which was a half. So, just to check that it makes sense. Oops, logret. Yeah, okay. Let's print only the drift. Okay, certain drift, a negative drift, so it will, in the future it will go down probably, slowly. Okay, now, future prices equal numpy, we fill it with zeros. How many? Well, we have 15 prediction for 200 trading days, plus today, sorry, yesterday, so 201, so starting from yesterday for the next 200 days, 15 predictions. Clearly, if you do the exercise not today, so but later on, the next years, it will be different, obviously. So now, future prices of 0. So all the first 15 future prices will be equal of the price of today, which is the prices, the start price dot iloc. Let me off -1. Okay, but I forgot something more important, which was, we can do it here. Okay, we have to calculate the daily returns, which we're gonna to use. So I need the standard deviation. Okay, I need the drift through. Okay, I need to convert the drift to an array. Dev true equal. Also the standard deviation to an array for technical reason. Okay. Now I need an array of percentages. Do you remember it was an array of random numbers? We need 200 random numbers for 15 predictions. So we create a long battery, a long matrix of random numbers. Okay, now z norm.ppf, this is the inverse of the normal function, daily returns, it's equal to numpy.exp. These were all drift. Well, according to my opinion, it's not necessary to convert these two things into an array. Okay, I will try later. But I can try to see whether the results are the same because everything is random here. Okay, that's it. Okay, now future prices. And now for E in range, we start from 1, we arrive at 2 or 1. Pay attention to where you start and where you go. Future prices of I are equal. These are the 15 future prices. I is this thing here, so I'm talking about the 15 future prices altogether. It's equal to the future prices of the previous price, so I minus 1. And this is the reason why my I starts from 1. You can start from 0. In this case, you will have future prices of I plus 1. And here you have I. Okay. By the daily returns. Which one? Well, honestly, here it doesn't matter whether it's the I or I minus 1. Because they're all random. So it doesn't matter whether it's I or I minus 1. But clearly, if for you daily returns has only 200 elements and you put I, well, when you arrive at 201, it will not work. So it doesn't matter whether you use the I or the I minus 1. The important thing is that you don't go beyond the boundaries of daily returns. Okay. Now, before plotting the picture, I check, because some of you plot the picture and don't realize that it's completely wrong. So future prices, I check whether it makes sense. So we start from 10.28. All are the same. Second is 10.10. It's going to see some predictions. And then the last one is, yes, makes sense. If you see that the last one, for example, is 0000, doesn't make sense. If you see that the last one is 2 billions, doesn't make sense. So pay attention that it makes sense. Now let's plot it. plt.plot future prices. Okay, yes. Here it is. So it makes sense. Some go up, some go down. Okay, fine. I save. Okay, the Python is over. Now let me check whether it's on my desktop. On the Mac, unfortunately, it's not the easiest thing in the world. On Windows, it's much easier. You can ask me why do I use the Mac? Well, to show it to you. Is there a way in the Mac get info? This corresponds to properties. Yes, I'm doing it on the 20 May. Yes. Okay. Now I copy it back in the network folder. Where is the network folder? Yeah, it's here. So I copy it back. And when it asks me whether I want to overwrite, I say yes, replace. Maybe I checked that I copied the right way. Eh? Okay. Pay attention to copy it from your desktop to the network folder and not vice versa. Okay, now I stop the video and to do the second part, the smart contracts.